The star Betelgeuse, a very large red monster found in the prominent constellation Orion, has long captivated stargazers and cosmologists because of its sheer size and splendor. If Betelgeuse were placed where our Sun is, it would extend out to the orbit of Jupiter, confirming its massive size. Despite being located around 642 light-years from Earth, its enormous size makes it one of the brightest stars visible to the naked eye. However, recently, Betelgeuse has exhibited unusual behavior, such as dramatic dimming and brightening cycles, which many scientists believe signal that the star is approaching the end of its life. The well-known physicist Brian Cox recently stated that Betelgeuse is on the verge of a catastrophic explosion expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life, yet will provide a remarkable opportunity for scientists to study one of the most powerful and awe-inspiring phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the cosmic radar for ages, but its recent unusual fluctuations in brightness have sparked theories that it may be preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a massive explosion that releases a vast amount of energy, radiation, and cosmic material into space. Betelgeuse's imminent explosion is anticipated to be a Type II supernova, a specific type of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it could be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would normally be catastrophic if it occurred close to Earth, Betelgeuse's distance of about 642 light-years means that although the explosion will be visible and dramatic, it will not pose any threat to life on our planet. Nonetheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will emit throughout its entire lifetime. Betelgeuse's explosion will not only be a stunning celestial display but also a critical moment for science. Experts are eager to witness this rare event from its beginning, using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a broad range of radiation, from visible light to gamma rays. One of the most significant aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to travel through almost everything without being affected. Observatories like Japan's Superkamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, offering an early advantage in observing Betelgeuse's final moments. The explosion will also provide critical insights into the formation of heavy elements. When stars explode, they produce and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is crucial for understanding the development of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have destructive effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the emission of cosmic rays and charged particles, could result in more intense auroras, extending the regions where the northern and southern lights are visible. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This display will captivate not only the scientific community but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds a sense of urgency. Observatories worldwide are preparing to study every phase of the supernova, and the data gathered will be invaluable, potentially transforming our understanding of stellar evolution, core collapse supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the scale of the universe. Specifically, the event will offer a once-in-a-lifetime chance to explore dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycle of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The social significance of Betelgeuse's explosion is also substantial. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as signs of major change. Betelgeuse's explosion may evoke a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This monumental event is likely to inspire renewed interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and documenting the same cosmic phenomenon from their unique vantage points. Betelgeuse's explosion isn't just a specific cosmic event, but also a stepping stone for future exploration. The data obtained from the supernova will inform how we study other stars, especially as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is vital as humanity looks to expand its presence in the solar system and beyond. Additionally, the explosion will reignite interest in the quest for understanding the universe's mysteries and our place within it. Supernovae are fundamental for scattering the components expected for life, like carbon and oxygen, across the universe. By examining Betelgeuse's blast, specialists can better grasp how the building blocks of life could spread to other planetary frameworks and possibly spark life somewhere else in the universe. The approaching blast of Betelgeuse is set to be one of the most critical cosmic events in recent memory. Its cosmic explosion will provide an overflow of scientific information, upgrade our understanding of the universe, and undoubtedly entrench people around the world. Betelgeuse's death will mark the end of a massive star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this notable event, the world will watch the night sky eagerly, anticipating the moment when one of the universe's most powerful forces detonates into view. For researchers and stargazers alike, Betelgeuse's conclusive journey will be absolutely awe-inspiring. As Betelgeuse approaches the final phase of its life, one of the more theoretical but captivating possibilities related to it is the potential for the supernova to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These cryptic forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some hypothesize that supernovae like the one anticipated from Betelgeuse could hold the key to unlocking some of these secrets. Supernovae release a tremendous amount of energy and radiation, and some researchers believe these powerful phenomena may interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy produced by Betelgeuse's cosmic explosion could provide clues to their nature. Such a discovery would be historic, offering the first direct evidence of dark matter, an elusive phenomenon that has puzzled researchers for decades. Moreover, there is the potential for Betelgeuse's blast to shed light on the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. By examining the behavior of light and energy from Betelgeuse's cosmic explosion, researchers could gather